Alright, ladies and gents, this is 2.5 implicit differentiation, next section here. Homework again is on the right. This is, I think, the fourth video with my red shirt on. I might keep going. I might see how many I can get done here. We want to distinguish between functions written in implicit form and explicit form. We want to use implicit differentiation to find the derivative of a function. So an implicit function is a function written where y is not isolated. So lately we've been doing, not lately, almost all the time, since we've been like little people, we've always been like y equals some function f of x, right? But now what's going to happen is, instead of we're getting like this, we're going to have other functions that look like this, where x's and y's are together, but then there might be some other y's somewhere in the problem that I can't say y is equal to x's. I can't do that. So this is where implicit differentiation comes in. So when differentiating with respect to x, any term with only x variables will be differentiated normally. Any term with a y must be differentiated using the chain rule. Okay? Because it is assumed that y is defined implicitly as a differentiable function of x. I'll explain what that means. I know you should have an idea of how to do it, but it doesn't mean you understand why we do it. Okay, so if I just do the one on the left here, it's pretty easy, right? Because these two match up, I'm just automatically going to do that normally, right? So this is just going to be 3x squared. Okay, that's pretty easy. Okay, but this one, because these do not match up, I'm going to take the derivative of this, which is 3y squared. But because they don't match up, I'm going to multiply that by a y prime, or if you wanted to, as dy over dx. Either way, all right, you can do that either way. Because we don't know what y is, we're not differentiating with respect to y. Hopefully we understand that since the denominator is an x, we're differentiating with respect to that variable. If the variables don't match up, then we need a y prime or a d something over dx. In this case, they don't match up as well. So that's going to be 1 times dv over dt. Or you could just write it as dv over dt, or you can just write it as v prime. They would be acceptable. All right, that's how you implicitly differentiate. Over here, this is going to be split up into two separate ones, so it's going to be the derivative of x over dx with respect to x, plus the derivative of 3y over dx with respect to x there. So here, I can do that, that's just 1, plus. Here, I can do it, but because they're not the same, I'm going to have a y prime or a dy dx in its place. However you want to write the dy dx or the y prime, that's up to you. I like to write y prime because it's shorter. But if you understand what it means, then you can do it. But if you don't, then please just use dy dx. The one on the right, this is product rule. Okay, so I'm going to say u is x, y squared is v, so the u prime is 1, v prime is 2y, y prime. Because the 2 comes down when the 1 stays there, and then I have to find the derivative of y, which is y prime, because it's with respect to x. So then I'm going to say, okay, u prime is 1 times v, so that's y squared plus x times 2y y prime. Okay, or I could say it's dy dx. So the variable that I'm hearing is up top. The variable that I want respect to is on the bottom. Okay, so here's some steps. You want to differentiate both sides of the equation with respect to x. Collect all terms involving dy dx on the left side of the equation and move all other terms to the right. Factor out dy dx and then solve for dy dx. Okay, so here we go. This is find the equation of the slope of each line. Okay, so what I want to do is I want to take the derivative of it. Right, slope is the derivative. So I'm going to take the derivative of the whole thing. So here we go. With respect to x. So it's dy over dx. So this here is 3y squared y prime. I am going to say that y prime is equal to dy dx because I want to, okay? I'm sorry, not equals. I don't know why I put equals there. Let me see if I can erase that pretty easily. There we go, okay? Plus 2y prime minus 5y prime minus 2x equals 0. There's no y primes there because I'm with respect to x, and there's no x primes because x prime. All right. So here, maybe you're not understanding. Theoretically, okay, if I say minus 2x, there technically is a dx over dx, but something over the same thing just goes away. That's why that's just 1. Okay, it doesn't exist there, and this is a y prime there. So what I want to do now is I want to keep all of my y primes over here and put everything else over there. So I get 3y squared y prime plus 2y y prime minus 5y prime equals 2x. I'm going to take out a y prime because everything's got a y prime. I'm going to take it out. Okay, then I'm going to divide everything by that, right? So it's really 2x over 3y squared plus 2y minus 5. This is your equation for the slope of that line on the graph. Okay. This one here, find the derivative. This is product rule. So this is 3x squared y to the third plus 3y squared y prime x to the third minus y prime equals 1. If you can't do product rule by now, you need to go back and practice. That's what that is. That comes down to this here. That's product rule. Okay. Hopefully I did that right, because if I'm making fun of you, that's not good. All right. I want to keep all my y primes over here. I'm going to move this over. So I get 3y squared y prime x to the third minus y prime equals 1 minus 3x squared y to the third. Factor out my y prime and then divide by it. So when I factored it out, I get 1 minus 3x squared y to the third over, now divide by what I factored, 3y squared x to the third minus 1. Right? I think that's right. 3y x to the third minus 1, 1 minus 3. Yep, that's what I got. Okay, there is our answer there. All right. What I want to do here is basically the same thing, but I just want to find the slope of the graph because it gives me the 0.31. So basically your 0.31 is, say, over here. This graph, because you have x's and y's here, it's going to react very differently than if it was just a function of x graph, right? So I got to find the derivative here. So there's a couple different ways I can do this. I can definitely use chain rule with some product rules and stuff like that, which let's probably do that. It's probably easier. So let's take the derivative of the left side. So this 2 comes down. It goes to 6 times the inside derivative, or inside stays the same. So y squared. This goes to 1. Multiplied by the derivative of the inside, which is 2x plus 2y y prime, equals now the derivative of the right-hand side, which the 100x to y, that's product rule. So we got to make sure we get product rule down. So it's 100y plus 100xy prime. Again, product rule. Make sure you have that down. If you don't have it down now, you need to go back and do it. All right, now tis not very good, but let's do some things. So I'm going to bring this over here to this side. Okay. There's really not much else I can do. I guess maybe distribute a little bit, clean it up so I get negative 100 xy prime. Oh, I don't need to do that. Here's why I don't need to do that. I don't know why I did that. Here's why. Because I'm not actually trying to find the equation of the graph. I just want the slope. So I'm going to plug in these points. So it's 6 times 3 squared is 9, plus 1 squared is 1 to the first power. That doesn't really matter, right? 2 times 3 is 6, plus 2 times... what do we need to do? Oh yeah, no, I'm good. I'm good. I don't know what I'm doing here. Okay, y prime stays there because that's what we actually ultimately, like, y prime is the slope, right? Is the slope. Well, we want a number there. We want a numerical value. So 2y times y prime, that is just going to be 2. Y prime, equals 100 times 1 plus 100 times 3 y prime. So we get 6 times 10 is 60. Sorry, I'm discombobulated. My daughter's screaming in the background, so I'm sorry. Times 6 plus 2y prime equals 100 plus 300 y prime. Let's distribute here a little bit. I get 360 plus, that's 120 y prime equals 100 plus 300 y prime. I'm going to bring the y primes over here and this over here. So I get negative 180 y prime equals negative 260. Divide that by negative 180. So it's positive 260 over 180. It can divide by at least by 10. Get rid of those. Divide by 2. And I get negative, I get 13 over 9. And that is equal to y prime. Okay, that's what I was looking for there. All that stuff, I didn't have to do a lot of stuff that I was planning on because it doesn't say equation. It says write the slope, find the slope of it, and it gives you the point that you're looking through. So that's a lot easier to do than just to find the equation. The equation would have been really tough on that one. All right, so this is a question that they might ask you. It's a little confusing because when we find the second derivative in any other function with respect to x, we just find the right side, right? Y equals 2x, and we find the derivative of the 2x, and we do it again, and we keep, it's pretty easy. But because I have y's in here, with respect to x, I'm going to have some crazy stuff to do. So we have to kind of follow along here and make sure we understand this. This is a little confusing. So this is product rule right here. Okay, so that's 4y plus 4xy prime equals 0. That's the first derivative. Okay, theoretically. So this is really the first derivative. But what I have to do is I have to solve for y prime. So y prime is equal to negative 4y, I brought this over here, over 4x. So the 4's go, so it's really negative y over x. So that's what y prime is. Okay, so that's great. That worked out pretty well. Now, because it's the second derivative, I have to find the next derivative using what I have for the first derivative, which is negative y over x. So that's quotient rule now. So remember, it's u prime v minus u v prime over v squared. And u is negative y, u prime is negative y prime. Okay, because of the, with respect to x derivatives. V is x and v prime is 1. Alright, now technically where a y prime is, I know what y prime is. I have to almost plug that in. I'm going to wait till the end to do that, but that's what I'm ultimately doing. Okay, so I'll show you here what I'm talking about. Let me erase some of this stuff up here, and let's go up there. So let's find the derivative of this, which is u prime, which is negative y prime x, because times v, minus v prime u, which is actually a plus, and then a y, so that's really easy, over v squared, which is x squared. Okay, but wherever this y prime is, I have to plug in negative y over x. So this is negative, and then a negative of a negative, so that's really positive, y over x times x plus y over x squared. These cancel, so I get y plus y over x squared, which is equal to 2y over x squared. Now, we can say this is really y double prime, which it really is, or you have to know the notation. This is the same as 2 squared y over 2x squared. That is the notation for double derivative using this notation. If you want to use y double prime, be my guest. But if you don't, and you want to use the dy dx, then you got to make sure you write it correctly. D squared y over dx squared. All right, that's proper notation. Fantastic. We're done with this video. It's probably a little longer. Sorry for the kind of in and out of it parts of the time. But other than that, we're good to go. See you in the next one. Deuces.